Practising Programming in C, where we're doing some more stuff to do with the error message printing. I think the first thing we're going to do today is spec out a little function that's going to handle UTF-8 for us. It's just very simple. And then I'm not going to do the actual UTF-8 part of it. I'm just going to spec the very basics of it. And then I'm going to just quickly remove some code that I just remembered is in there from previous when when I started to track comments and new lines. I started to push those on as tokens, push them onto the token stream. I've since stopped doing that, and since stopping to do that, I no longer need to do something that I did have to do when I started to push them on. So that's what we're doing. And I think this tokenize function is actually the very place that's going to need this function. Yeah, handle wide UTF-8. So yeah, basically what this is going to be, this string content is going to be like, I could leave it as content, but I'm just gonna say it's car, and it's going to be equal to a get character from buffer, and we are in B, right? That's where we are. We're in that buffer, and then what we do is we say the advancement is equal to the car length. And this person down here takes that car, right? So here's our buffer, and what we're going to first of all do is obviously my result of and the result length is going to be 1. But then we need to do some logic in here which determines what kind of a character this is. Right, is the character like a wide Unicode? I don't actually even know what you kind of call it, but is it the kind of character that we need to handle, especially in this case, or is it not? So I think if I run the config thing now, we shouldn't see that. You see this? We have this config warning on line 85 of Cinera.conf. This is referring to this character here, which is a Greek question mark. Believe it or not, it's not a semicolon, but a Greek question mark. Now we've just hard set this length to be 1. So what I reckon is going to happen here, when I run it, is we're going to get 2 config warnings on line 85, and the unhandled character is going to show up as nothing. It's not going to be able to print it because it's only one half of this character, and that's exactly what we do get. If I, however, change this to 2, we should get it back. Yeah. So basically, that's what we need to do. We need to just learn how to actually determine the extent of a UTF character. And I guess you could also say get UTF-8 character from buffer, so you sort of know that that's what you're dealing with. And also, I would mention that we're only doing this in one place. We're doing it literally just here, so that we can report that we're not handling this character, or whatever character we get. We're not going to use it to sort of determine the extent of a string, and we're also not going to use it to report the column number. As we're reporting the line number, we could report the column number but I've decided against doing that. It might not be too difficult, but yeah, I've decided not to do it. But if we were to do that, I think what you'd really need to do to support this stuff properly is just add to the string struct. You've got this length here. This is the number of bytes in this string. At least the way that we're currently doing it is it's literally just the number of bytes. You'd have to have a different thing, store a different value, which is like the number of characters, the number of like printing characters, if you like, so that you can do stuff like tabulate the data. You know, so you can figure out how many spaces you would need to like put in to how many spaces you need to add to, like, for example, to either side of the string in order to make it like line up with other stuff, if you know what I mean. So yeah, that's probably something you would have to do, but we're not bothering. All we're going to use this for is literally just so we can report this unhandled character. So there we go. I think that's all that we needed. And also I think unhandled character ignoring, just so the user sort of knows that that's what's happened to it. It hasn't been processed. It's just been like, this has been treated as if it's just simply not there. So it's going to go on and it'll see unit. So when you see something like well, what would you be seeing actually? Configure unit. Doesn't unit get... Yeah, syntax error. Yeah, it's this bottom one, is it? Received unit but expected a semicolon or a opening brace. So when somebody sees this error on line 86, they can sort of make sense of this error in terms of this unhandled character having been ignored. Yeah, we've told them that it's been ignored. And obviously it's wrong now because we're just saying that the number of bytes in that character is 1, which isn't true. So skip, it's not skip white space, it's skip contentless token. And then I believe in, is it scope tokens? The other person. Yeah. If the current index is less than the T count, I think we don't need this check anymore. Okay. Yeah, we're getting all the same behaviours as we had before. Now, I will just back that out just very briefly. Let this happen. Because I think I'm right in saying that we had to do that because we are getting a we were infinite looping, but we're not infinite looping, are we? basically what was... Oh no, it wasn't that. It was all this lot in addition to the fact that we weren't so we were letting the new line get pushed on. Well, that isn't bothered for either. Yeah, I don't know. I think I'll proceed anyway. And remove this notion of skipping contentless tokens. I might have to go back and watch the video to see where we needed to insert that additional check, just to make sure that I don't screw it up. And this check was, so this is the one that I thought I needed to change, or rather thought I didn't need to do anymore. I guess I could loop over the current index. Could I just look for that? Pass include rule. So this isn't really checking that. So yeah, okay, I presume that it must have been this. I think it must have been this one. I needed to add this additional check just to make sure that we had actually got to the final character, final token rather. But yeah, like I say, I mean it's working, isn't it? Yeah, I think we'll just keep a bit of an eye on that, and I think I will also go back and check out the video to see if that is actually the place where I needed to do the thing. So we're doing UTF-8 here. Get UTF-8 character from buffer, and all we just need here is a bit of logic in here, which tells us how many bytes we're dealing with. Here we go. So number of bytes 1, 2, 3, and 4. So it could be 1, 2, 3, or 4. So the first code point is going to be base for code point 7, 11, 16, 21. So byte 1 in this needs to be 0. Byte 1 needs to be 110. Is it in, if there's 2 bytes, it's got to be 1110 if it's 3, and 11110 if it's 4. Okay. So I guess you just don't even need to set the length straight up, you can just check out the first byte. Okay. So And finally, else is to be a failure. So what is the test? I mean, I guess also oh right, yeah. Right, so if I need to make sure that the first bytes I think what we're supposed to be doing is talking about a mask. Is that it? I mean, that seems to have done something. On handle character ignoring. Why am I getting an extra line though, I wonder? Just run that again. Um, Three, that turned out to be. So 1110. Interesting. I mean, it's possible that I haven't got this right, by the way. But let's just read this a bit more carefully. Because essentially, we should expect that particular character to result in a length of 2. I think. The X characters are replaced by the bits of the code points. Oh, I guess you need to mask out the bottom bits, don't you? That's probably what you need to do. Um, yeah, it's totally not sufficient to say if this ended with this. So you don't care. Oh, and also, this has a different structure for different bytes, doesn't it? Bits for code point. Also, we will need to check that we're even we've got enough characters left in the buffer. So what I'm kind of thinking is that we could we could figure out 4 first, right? So we shift this number 3 bytes to the right and then 3 bytes to the left. So we end up with zeros in the bottom bits. I think actually we also need to save off the value of this value before we do anything with it, actually. I think that's something we'd have to do. We do need to check all 4 bytes to see if that thing, to see if the if bytes 2 to 4 all begin with this. Do you need to do that, or is it sufficient just to sort of check this? I mean, if this is true, nothing else, it can't be any of the other ones, right? Which suggests that you should just be able to check byte 1. And then, as long as you have got enough buffer left, you can assume that this thing is going to be 4 bytes long. What are they called? Do they have a name for this? Trying to encode code points in 1 to 4 bytes, depending on the numbers. The following two is structured encoding. The bits of the code point. Yeah, they're definitely really. Zero zero one two, so that means it's 0010. Well, they've got 2 bytes, yeah. Yes. 0010. Well, hold on a minute. Do you read it the other way around? Because the encoding will be 3 bytes long. According to the scheme table above, this will take 3 bytes to encode, since it is between that and that. Hexadecimal 20 is binary this. The 2 leading zeros are added because, as the scheme table shows, a 3-byte encoding is exactly 16 bits from the code point. So you've got 3 bytes, 16 bits of which are used for the code point, so 4 are reserved. One, two, three, four, five, six, 7, 8. 3 bytes. Sorry, yeah, 8. 8 bytes of which is going to be used. 8 bits is going to be used for this information. Exactly 16 bits from the code point. The 2 leading zeros are added. Because the encoding will be 3 bytes long, its leading byte starts with 3 zeros. Okay, let's just read this whole thing through. Then a 0. The four most specific bits of the code point are stored in the remaining low order 4 bits of this byte. Leaving 12 bits yet to be encoded. We need that so it won't be encoded in the lower bits. 12 bits, so there's going to be 4 bits remaining for the actual other stuff. One error is stored in high order, 2 bits to mark it as a continuation byte. Okay. Plus is again that is stored. Another continuation bit. Continuation byte. The 3 bytes can be more precisely originated first of all. Yeah, whatever. Four bytes. So we've got 0 is the first thing. Not sure if I've been any the wiser really. Other than to say that I think well, it was seeing if we can just assume that these are all fine. We can check this. But yeah, let's do this thing. First of all, let's do them in reverse order as well. Okay, so byte 1. Shift it down 3. Well, hang on a second. How do you do that? How do you do like multiple things? Right. So that's just clearing the bottom bits. And then we want to be seeing oh right. Sorry, how do you do this? Can't you just shift that down like that? Um, I sort of want to be able to fall through here. I mean, basically, it's like going to be else. We're going to take the byte 1 equals byte 1 shifted down 4 this time. And then we then do an if. Well, it's this case here. Right, but if that still ain't the case, then you again go in and do this. So we're still getting, we've got 4 again. So we shifted by, let's step in and see what I'm doing. It's kind of interesting that we are printing out the right character, but is that just pure luck? I mean, we're reckoning that it's 4 bytes long. 4, 3, 2, 1. I guess. I mean, we're also not checking that we've got continuation bytes. Oh, actually, so what have we got? Oh, it's a normally. So did we only? Oh, we only get there once. Okay, fine. So here we are. We're at our Greek question mark. Possible I'm not even doing anything about that first byte. Okay, so we've got minus 51. If we shift that down by 3, get to 7. And then we end up with minus 56. So we have done something with that. It'd be nice if I could print this as like a byte. GDB Okay, this is what I'm talking about. So examining the unit. So that's hex. I think I want to view it F is the format. Print. Hexadecimal initially. The default changes each time you use either X or print. So that's decimal. Probably octal. Yo, dude. This is what we're talking about. We want to. We're doing UTF-8 stuff. Okay, so this is what we've been dealt up. So I wanted to see, so X and then T on byte 1. I think what I'm going to do is I'm going to rerun, now that I know how to view this thing, and just inspect byte 1 before doing the shift, just to see if the shift is doing what I expect it to be doing. Okay, so we have got stuff down in the bottom 3 bits. So all I'm trying to do here is clear those bottom 3 bits. So we just shifted down by 3. So we've filled the top 3 bits with 1s. And then we're going to shift back down, or back up rather. And now we've successfully cleared the bottom 3 bits. So now I'm saying if byte 1 ended with OB000, well, OB11110, then the result length is equal to 4. But ANDing it with that should not be true, should it? I mean, can I just do... That isn't true. That isn't true either. So what is byte 1 at the moment? Byte 1 is 1100. I think I need to brush up on my bitwise logic here. Oh, hold on. Is it if that or... So we've cleared the bottom 3 bits out of that. And we just want to be seeing... Well, actually, sorry. We want to be checking against this, don't we? If that is equal to 0, is what we want to be seeing. Isn't it? Or rather, if there's no difference between them. How about instead if you masked out the top 5 bits and tested them for the magic value corresponding to this boolean? That helps you don't have to shift. So that's possibly like how I should do it. The AND will do the masking. Right, okay. Yeah, I was thinking do it the other way around. And do it in shifts so that I can preserve the whole thing. You know, I can shift down by 3 and back up to have just cleared those. And if this is getting the correct value, then we use it. Otherwise we could then go on to do the 3. And we've still preserved all the information that we need. Whereas like if you mask out the top, well, I mean mask out the top 5, we just simple switch them if you do that. Ah, that's what I kind of wanted to do as well. I wanted to do a switch. Yeah, right. Let's see what you. Let's try out this anding. So we've got the byte 1. Tell you what, let me just have a quick gander at how I do, because I definitely do shifting in. Sorry, do bitwise stuff in here. I think it's credentials. Oh no, it's reference. It's reference. Build reference. Yeah. So start with a mask. Interestingly, I'm not anding, am I? I'm or equalsing. Okay, so you have to do the else if for masks and test for specific values. Then you can switch state, I guess, for the resulting mask to get the code point information. Guess. What we want to separate by length. Yeah, it may be used to clear selected bits off flags or register, in which each bit represents an individual Boolean state. This term is a efficient way to store a number of Boolean values you can get as little memory possible. For example, this can be considered a set of 4 flags, 0, 1, 1, 0, where the first flag is clear. So this ANDed with this gives you that ANDed with this produces that. So, okay. So it only gives you the thing if the 2 bits are set. Well, I mean, strictly speaking, it's just that, isn't it? I think. Well, I mean, that won't actually tell you though, will it? Because 0B1 is going to match against that and the rest of it. So I guess you do it like, I guess you kind of do have to do it that way. See if all that matches, or rather that way. So that will give you, will it give you the same result, actually? Now that I think about it. I suppose technically, actually, you also want to do the whole lot, don't you? Is that true? if those 4 bits are set and the other ones are not set, well, the thing is we can have 0 and 0, couldn't we? Oh no, wait. Okay, so 0 and 0 doesn't produce that. It only produces 1 if both of them are set to 1. Must be the bottom 4 bits width, right? Okay, so if we mask out those 4, get those 4, and if we just say if byte 1 is equal to that after having done that, then we know that it's right, we know that that's the case, don't we? And also, because of this, I was sort of thinking, do we need to check what bits do I want to know about this particular byte? I just want to know about the... So for this one here, I want to know about the top 5 bytes, don't I? Yeah, I think that's what I want to know. And then I want to be matching that. Ah, yeah, I suppose C sort of saying I could just do this. I mean, are they different actually? Okay. Oh, I see. Interesting. So if we've got that's 4. Okay. So yeah, I think we do need to check the entire thing, don't we? But I suppose he's sort of saying you can do sort of or equals to those bytes. Maybe. Ah, right, you could get a malformed. I was wondering about that, if you could actually end up with that. Let's see what happens if I do this full check against this whole thing. For the first byte, you want to know the first 5 bytes. I do, yeah. Yeah, I want to know these 5. Yeah, I should have highlighted the whole lot. So you want to render the bottom 3 like irrelevant. doing the bitwise stuff. So if you give them 1 and 1, you'll get 1, 1, 1, 1. So in all of these cases it'll be 1, 1 and 0. So I've switched out on this 5 bytes. 5 bits. So he's switching on those, he's sort of saying if that case ended with yeah, it's just 0, isn't it? Oh, I see. So for each of them, so you just get that, and then you're switching on byte 1. So having masked out that, is this true? You just switch on that and you say if sorry, switching on. Well, hold on, before I do the switch, actually, let me just I think I might just write these out a bit explicitly, just so I can get a bit more of a handle on what's possibly happening. And also maybe, yeah, I mean we should see this, shouldn't we? Also we need to check, as you were saying, check for the malformedness. So yeah, we're clearing out all the bytes just to make sure of that. Okay. So we're stepping in to the unhandled thing. It's not there. It's there. So run to here and step in. So byte is going to be equal to is it xt? So byte 1, xtb, I think is what we should be looking at. X tuberculosis. I think this looks reasonable. So we've been served up a minus 51. Which I believe we've got, which I assume is this. I see. But if we now let that happen, we've successfully cleared out the bottom 5 bits here. One, two, three, 4, 5. What? Ah, hang on. Oh, interesting. And that's what we need, right? And then this one here should be ineffective, shouldn't it? Because when we do this ANDing with 1110000, it's going to produce the same thing, isn't it? Because these two are going to be set, but this one isn't. So it's still going to be producing the same value. Interesting. Awesome, dude. So see what you mean about switching on it, because you don't need, this is rendered ineffective. And I think I think equaling is the right check as well, isn't it? Like we should get into this, shouldn't we? We don't get into that. I've had enough. 1, 2, 3, 4, 5, 6, 7, 8. One, 2, 3, 4, 5, 6, 7, 8. I think when we do this, it should clear the whole number, shouldn't it? Yeah. I mean, does this pass? That does pass. So so that's 1, 2 is 192. And if at some point we did say that the byte 1, and I guess you could also print out byte 1 as the actual thing. Now, is it signed on? Yeah, signed on, signed problem. Because a car is going to be signed, isn't it? Yeah, because when it comes in, it's saying it's minus 51. So I guess this is supposed to be evaluating to 192, but if it's signed, then this is going to have to be a minus number. So I guess you cast it. So who are you casting? You're casting byte 1 to be signed. Sorry, unsigned. Let's just do it as a U. U. And also, we can switch like you're saying. Obviously that's ineffective, but let's just see what bytes 1 is currently. It's a minus 64. 64 is a power of 2, so it's presumably we've got one thing other than was it tuberculosis. We've got one thing, one bit other than the high bit set, which is what we have got. And yeah, like if we print this again, is 192. Oh, interesting. Okay. Oh, because of the fact that this blows off the... Yeah, this changes the value, doesn't it? I mean, I guess couldn't you do the switch for the top, for the 4, 3 and the 2? And then if you still haven't got there, then you peel off the... Well, hold on a second. If none of these are right, I suppose actually you could do this check, do this ANDing, couldn't you? To peel off the top one. But it's still not, is that right? The right thing though? Yeah, we're doing the check. Are we now getting there here? Which is what we need. Let's produce the error. So let's just try some more. Let's just try exhibiting some more of these errors. So we've got these. And let's just do them in order. So I think we can't catch the dollar, but we can catch that because we don't handle that as a character. 0939, we don't know what character that is. We don't need to. I presume it's printed out the right thing. Okay, got that. Hold on. 10348. So I presume it's put the actual proper character. I guess we could have checked that. Yeah, I just seem to have put the right character in. Yo. So hopefully we should see what happens with this one, which would be interesting to see. Well, we'll see what happens with them all, actually. And actually, let's put them the other way around. So we can go through them in the order that they come in. So go to the 4, 3, 2, and then 1. And why have I got 5 characters here exactly? 1, 2, 3, 4, 5. Oh, 2 of them are thingamajigged. Okay, 2 of them are the same length. Right. Gosh, that's why did they do that, I wonder? What's that supposed to be teaching us? So it seems like they're showing us absolutely nothing at all. So yeah, Let's leave that one out of the picture for now. One, two, three, four, five. Didn't I just delete one? Start again. So we want the one with 4 first. 10348. 20 air conditioning. 00A2. And then finally the hash. So 1, 2, 3, 4. So we've got 4 characters that we want to be testing our thing on. So we are there, aren't we? Probably can't do this, can I? Okay. Yes, okay, so we're getting there. Again, we're performing this to knock off the thing, but we don't necessarily need to do that. Tuberculosis. Because this is already determined. I think, is that actually true? That when you do that, this has to be 1110. So, yeah, I mean, I suppose that is just true, like, no other character could accidentally be 1110, and then some stuff. Or rather, I guess it just does, it couldn't accidentally be 1110. So I guess, yeah, that's fine. Got a master that's 0. Yeah, and then again we're getting there. Yeah, so the first 3, the 4, the 3 and the 2 have all worked. Oh shit, I should have actually checked out the byte 1, shouldn't I? Although I think we have agreed that that's fine, haven't we? Well, hold on, this is already 0. Yeah, dude. Because we've masked out the top 5 bits rather. If this is 0 and there was a 1 in there, it doesn't matter because it's ended up 0. So we're fine. That's the top 5 bits. Yeah. In the first thing. In this one up here. And then this would have been the masking of the final top bit. It's the only 4 masked. Oh. Sorry, yeah. Well, I mean, I'm asking the entire thing, aren't I? I'm sort of saying 4 bits set, and then 0, 0, 0, 0. Right. And if that thing, if this guy is 0, then this masking here is going to end up producing all zeros anyway. Isn't it? I guess unless it was like 0, 1, 1, 1, 1. So I suppose technically, to be fully correct, you do want to mask each one, maybe. Is that true? Take for example 0. Okay, a malformed uint. You don't think that could tell? Right, okay. So what have we got here? 0B 1 1 1 1 1 1. I see. So that's not a valid byte. I've got you. So, so if we run to here and step in, so byte 1 is going to be equal to that. So byte 1 is currently -3. We've got 5 bits. The top 5 bits are set. Now if I mask out that, I end up with 1 1 1 1. Ah. But I need, well hang on, that is right. Such that if the 5 bit from the left was set, you would know that because it wasn't masked out. The 5th bit from the left was set. If the 5th bit from the left was set, you know because it wasn't masked out. So we just perform the mask with 4. Well, hold on. If I were to do it with 1 1 1 1 1, and I received 4 top 5 bits, then I would be seeing 5 bits set, wouldn't I? Which is not. Oh, I see what you're saying, right. I've got you. I see what you're saying. Yeah. Sorry. I was a bit kind of not understanding the problem there. So, yeah, if you do this, then you make sure that you've got those top 5 bits set as they actually need to be set. A nice pattern to the top bits. Yeah, I mean, I have done a bit of bitwise before. It's just that I don't often do it, so it sort of slips out of your mind. That's a nice present. Now the thing is here, like, so if I just follow this thing down, right? So I need to mask out that, and I need to ensure that it's this. Having done that, let's just do it all, right? As he's suggesting. So we're masking out the top 4 and checking that we've got 1110. Mask out the 3, and then check that we've got 110. And then finally just mask out the entire thing. Well, I suppose it's like, sorry, it's mask out the top bit, isn't it? And check that you've got this. And then I guess if you haven't returned, then you know that you've got a malformed thing. Yeah. Good call. Yeah, I suppose if you got down here, well, I mean, what do you do if you've got a malformed character? I guess you just have to sort of say, I'm sorry. The result length is 1, and we just return that. I guess you could actually report that it's a malformed character, but you still need a way to get past it. I mean, what information have I even got in here? I don't think I've got any information that I could even report with. Please read your syntax. I think that would be an error, though, wouldn't it? So fortunately we've managed to, by pure luck, end up breaking there. So that's a good point actually, yeah. Oops, read my red. Please correct your text. Oh, I'm gonna lose the breakpoint here, aren't I? Okay, so we run to there. I think we haven't given it. We've got the failure case in that function, haven't we? Yeah. So having masked at the top 4, 5. Minus 3. And we want to be seeing that the top 4 bits are set, which they are, but also the 5th bit is set, which we have correctly established. And then we're going to mask out the 4 and see if we've got 3. So we have masked out the 4, but we don't have the 3. So yeah, it also seems like well, could you get away with having just? I don't think you could you? You couldn't get away with just masking out the 5 and then relying on that being correct all the way down, could you? So we're going to say what? So okay, so the one is going to be set. So this is going to result in 0B1 0 0 0 0, which ain't right. Yeah. Oh god, laughing stock coming off. Do we even have paperback writer? Got a feeling I don't. Yeah. Oops. So this is all working, isn't it? But I guess the question is, let's now let the actual thing do the proper characters, and just see what they ended up giving us. Tower standard's going to be on 4 bytes media 8. Okay, same thing. Well, how close are we to increasing insight of each? Yeah. Yeah, I was going to say, how close are we to being full? Because I don't think we can't surely be very close to exhausted the limits of like 64-bit memory address space, can we? What does give us? So I'm asking at the top thingamajigs. By the way, you all just spotted that Laughing Stock was queued up. It's just started. If you haven't heard this album, I just couldn't recommend it highly, any highly than. There are no words to recommend this album. We've only used 2/16 of the 4 bytes. Okay, cool. So we're going to mask this person. And this is right, isn't it? We've got this is the 4-byte version. This first character is the 4-byte one. So this is the test, isn't it? So we've got 1110 coming in. If you mask out the top 5 bytes, it's just going to give us the 111, isn't it? Which is what we need. So yeah, like you're saying, Jesse, we can just totally switch on the thing, can't we? We can switch on byte 1, caster to a UTF-8. In fact, for all that, why are we bothering to do that? Might as well do that. Right. You can just then switch on byte 1, caster to a switch on byte 1. Seeing if it's 0B, that. And then finally check if it's byte 1. Finally mask out the top bit, see if that is this, and then if it isn't, if you've got all the way through there, that's a valid thing, which is a valid. Yeah. This is why you don't think switch statement wouldn't work. I think I get you. Switch statement wouldn't work. Wouldn't work. So yeah, when we mask get this dude out, like I say, we're just going to end up with the top 3-bit set, right? Which is precisely what we want. I mean, strictly speaking, we should also go down this route as well, shouldn't we? Seeing if all these dudes are correct as well. So that doesn't pass. This should pass, shouldn't it? Even without doing the mask, because we've got the 3 bits set. So we've got 1-1. Trying to untangle this this old statement. So yeah, we masked off the top 6 bits, and ended up with that. This isn't going to make any difference because we've already masked them off. Zero, yeah. That's the top 5, and then we've ended up with 0. And this is where we would need, for this case, to actually mask off the top 1 bit to make sure that the top bit is actually a 0. Yeah. So that's a valid UTF-8 that if we just mask out and try to switch to it and get its byte length using the mask, that it wouldn't work. 1. Oh, right, I see. 1, 0, 0. Ah, I got you. I see. I'm with you. Totally understand. Yeah, basically what you're saying is, if you set your mask to 1111, 5 ones, then you're going to end up with all of these set apart from one, apart from this bottom one. So then when you come around to check, when you come around to do this particular check here, or it'd be this check, won't it? When you do this check, that'll fail because this bit, this 5th bit down is set. So maybe you just do it like this. And I guess, yeah, as we were saying, just to be doubly sure, just go in and do all the bytes. Right, if you see that this, if you're in danger of finding a valid byte, a valid character, you then go ahead and you just check that these guys are actually as they should be. So yeah, let's do that. And I think I understand how this whole stuff is working. So yeah, let's do it without switching. I think what does this return again? Oh, it returns a string, doesn't it? Which is a little bit unfortunate. I guess we just have a custom error message just written in here. I think, can you do anything about this? Well, you can't print the file name and line number. So the question kind of is, what would happen if you have got an invalid, like a malformed character in your file? What would happen in that case? And what do column numbers, what do line numbers mean in that situation? Do you know what I mean? Could replace invalid cards with question mark. Yeah, why are we passing errors? Should we just see what actually does happen? If we just edit one of these characters to give us an invalid code point, just see what it looks like. See what Vim does with it. Because I'm just thinking in terms of, do we need to bother about actually reporting the error ourselves? You can use the top bit to scan forward to the next starting byte. The top bit, okay. Top 2. Alright, yeah, to make sure that you've got the thing set. Oh yeah, right. So this is what I am trying to do. Part of this whole thing, I think I've got you. So basically what this is going to be doing is if it sets the length to be something, right? So you return a string, and then upon doing this, you set the advancement to be the length of that. So then when you come down here, you actually advance by that number of bytes. Let's see. So you skip the code point altogether for every byte after a malform when you test the top two bits to see if you skip it. Oh, I'm with you, right. I see. Interesting. So if we get down here, I think what I'll do is, let's just establish the idea of actually checking the subsequent bytes. Because I do need to check, like the length, the remaining buffer, essentially. And also that whole issue about not being able to print the error, I could just make it take the stuff that it needs to take. So yeah, if the byte 1 is equal to that, then what you want to say is if the B pointer +3, take away the B length, B location is less than the B size, then you can just queue up the rest of the bytes, basically. Sorry. If B pointer +3, take away, well, a specific call like that in a die for the purpose. Ah, okay. Yeah. FFD. Just sitting there, replacement character. Specials. So there's a bunch of interlinear annotation anchor. Mark start of annotated text. Mark start of annotating characters. Mark start of annotation block. Okay. So there's not a sign, but maybe used to detect byte order by contrast with FEFF. Yeah, and you're not seeing something. I can't see this either. It's not a principal character. So apparently there's a glyph for this, but it's nothing. Okay. So if this, then we say the byte byte 2 is equal to the value of, well actually it's probably more like that. And also you might as well just mask it out while you're here, mightn't you? Sorry, yeah, you need to mask it like that. And then if byte 2 ANDed with, if byte 2 equals this, if they all equal that, I think. I mean, we still do need to return somehow. Oh, I see what you're saying though. If yeah, because we're going to handle the malformedness down here, I suppose. Should we just see if that even passes? I wonder where that the old breakpoint is. So we should be getting in here, shouldn't we? I think we remembered. Yeah, that is what it should be. So they're all fine. Okay, so that worked. So I guess just do that for the other dudes. And also it's not really that, is it? It's kind of that. And then I think you don't need to check any more bytes if there's only one byte. So deleting byte 4. What we're missing? Oh, it's the that. I think that's all right. And then the byte one here. And if you haven't returned by now, then you do what interference says, which is use the top 2 bits to stride along. So you're basically trying to stride past invalid characters. So you want to straight the top byte is now let's just say that you've got an invalid first byte set, but then the next byte that you look at is one of these dudes. Right, that ain't going to show up with that, is it? Or maybe it is. If you mask at the top bits, you'll... I guess you could say if it is equal to this, or this, then you sort of just... Or rather, if it isn't equal to either of those two, then you just keep on going. You just get past them. Yeah, just keep peeling them off. I also shouldn't be moving the B pointer here because it's specifically the outer person who uses is going to be using the length of this to advance the B pointer. And also, let's also just say for honeybee. You see, this is some high class emoticon interpreting here. Honeybee pointing. So if we've got all the way through here, well, we don't want to be moving this actually. You want to be saying if the B pointer plus I, well, the B pointer, take away the location, plus I is less than the B size, I think is what you want to be saying. And then you want to say byte. B pointer is I. The question is, do you want to be looking at the actual pointer? I think by the time you got down here, you've established that something's busted, haven't you? So I think we should be able to reasonably just go back to the beginning. Well, I mean, I suppose you could also just do that. And the entire point of this is that once you've figured out how far you need to go, I think you want to be incrementing the length. So the length is going to begin at 0. I guess maybe start at 0. Also, I mean, I could just roll all this logic into here, couldn't I? Maybe not. Because I'm kind of what I'm sort of wanting to say here is while byte sorry, you need to actually master do, don't you? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the byte is going to be equal to that answered with that. Well, actually, if this is the case, then you escape. Otherwise, you increment I, and you also increment the result length. Right, and then once you've got out of here, you then decrement the length, so that you're actually back. You're not going to jump past the actual valid character. Honeybee pointing to that's right. Honeybee right. What's this? Is this an actual just a plus sign? Just a regular plus. Are there not any more exotic plus signs? Got the plus minus. You got a modify letter plus sign. Got this plus, invisible plus. So for some reason there's an invisible plus sign. Let's see what that shows up as. Got the eye. So that's in Symbola. Yeah, I don't get this at all. I'm sure that I have. I'm sure that your XVT is supposed to be displaying Symbola. It's possible it's just the size of the font that's busted. Yeah, okay. Let's just give ourselves so I know it's only the 1 byte. But hopefully it could give us at least a bit of information. So we've got a breakpoint down here as well, have we? Or up there. That was where that person went. So we've got the first top 5 bits set. Right. So we're now getting a new, well, bollocks. Unfortunately, we're just going to be setting we're going to be using the actual thing, which is unfortunate. And the plus is the kiss. I know, yeah, like, what did they have to say about that? There's a tag plus sign as well, which got fuck all. Not a principal character. There's a musical plus sign. Not sure I've ever seen that. You see this for something. I can't exactly remember what it is. I think that's like indistinct. Like it's like when you know, they can do that for like just a great big chord. Or maybe like when you can like hit on the body of the guitar. I think they indicate that with that. I don't think I've ever seen that before. Contiguity. Operator indicating. Mute. So yeah, unfortunately we're not going to actually hit this test. We are going to increment the result length from 0 to 1, and then we're going to decrement the result length back to 0, which is unfortunate. I think we might have to actually we might have to just dock to this guy quickly. So let's see how we do that. Chipsall's Super Hexagon soundtrack. Right, okay. Can you save in this thing? I have literally no idea how to use this. So for some reason also we've got like, what's happening here? Oh, I'm overwriting stuff. Right, okay. Well, hang on a second. That could be fine, couldn't it? Yeah, I don't really know what I'm writing here, but so I don't know what errors we're going to actually exhibit. But at a guess, they are not valid characters. So having done this, what program am I using again? Was it D-edit? D-hex? Okay. So, just out of interest, let's just load it. Okay, so the garbage. So that's what you're seeing in Vim. Cool. And that's gone down to here. So yeah, I guess it's just fucked up the parser, hasn't it? It just doesn't know how to read any of this stuff. It doesn't know how to read most of it properly. You see some of these guys, I think these originally were our test characters, which it's managed to screw up. Okay, cool. Yeah, I actually need to go to, so config warning on line 1. See, we're evidently not exactly right already, you can tell. Let's see what we're actually doing. Probably not being run. So, step into here. We've been delivered 5. Right, that's nice. That's kind of handy that the first one is one of these test cases. Well, hold on a second. What is actually... That is minus 54. Yeah, I mean, I guess that's fine. So yeah, we're not gonna pass any of these tests. So then what we're doing is we're gonna go into here. See, we are incrementing the result length, right? So we should at least surely be churning through the file in some way, shouldn't we? So there's our byte 1. Let's have a look at that byte pointer like this. Yeah, right, because this itself is a pointer. So you just look at it like that. So we've been delivered this, apparently. So unfortunately, Yeah, I see. We're going to encounter this. But why didn't we... If the first two characters are that, right, shouldn't this have actually passed? Oh, shit. Did we actually did we enter one of these and find that just one of these wasn't right? So we need to actually start off at least some way into the thing. Let's just reload that. Well, not reload, but just rerun it. XTB. And it was like that, wasn't it? So apparently this first character is a 1-1. 110. So apparently that's that. And I assumed that the second byte just isn't one of these. So my assumption here is that we should enter one of the cases and then find that one of the interior tests fails. We should pass this, shouldn't we? Why didn't we pass that? Because it was 1-1. Oh right. If byte that or byte equals that, so we're ending. So all we're trying to do here is mask out the top two bits. So 1-1. So this shouldn't pass, should it? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. So they're both bytes. Check where byte 1 is initialized. Oh shit. Yeah, let's try that one more time. Did I actually build that? So, let's try that again. Let's just see, what was it? Tuberculosis, byte 1, before we do anything to it. So it's 1-1, 001010. Yeah, I guess I wasn't looking at byte 1, was I? I was just always looking at the pointer, I think. So 1100. So yeah, so now, under this understanding, I would expect us to get into one of the cases. this case here. Jesus, and we do. And I think also we want to be actually starting off our loop at least some way in, don't we? Because 1, 1 is actually invalid. I guess we could have a look at what is b pointer 1. That's 1, 0. So we need to be seeing if it's 1, 0. So we're masking out all of these. Oh, sorry, we're only masking out the top 2. And we want to see if we're matching that. So we're not going to be, we're going to be, well, hang on a minute. Is this not a valid byte? I mean, maybe by chance that is actually a valid byte. Could that be true? So this will pass, won't it? So now what do we end up with? So that is not a valid byte, is it? Or is it? Well, hang on a minute. Why could that not be valid? I mean, if it's 1 byte, it only needs to be 0 at the top bit, right? So this is, oh right, this is a half. So this, right, yes, this is fine. So just by chance, this one is also fine. So let's just continue to the next dude. And now we've got that control P. So we've now got 0, 0, 0, 0, 0, 0, 0, 0. Well, won't this also be fine? Because it's zeros. Right? We're going to hit this. And we're going to pass this, aren't we? So we've got 4 bonds. This is valid, isn't it? Ah, so this is valid, but the bytes 2, 3, and 4 might not be. So okay, so this shouldn't be valid, should it? We should find that we don't pass this. And it's going to be this character that's going to throw us, throw off the test. Oh. Well, mind you, so we had to come into here somehow. So we know that the first byte is this. So when we come through, well, shouldn't our loop down here? Shouldn't this person be saying, this shouldn't pass, should it? Right? Because the top 4 bits were set. So when we come down here, we shouldn't break out of this. Because this isn't going to be, neither of these are true. we're going to have 0 be 1 1. Oops. You know, so in other words, what I mean is, we don't necessarily need to actually start anywhere in particular. Like, we don't need to start anywhere other than at the B pointer, because it will catch it. If it's malformed, it'll just catch the thing, won't it? So we expect to fail this, right? We're going to go through. And then we come into here. Now what we need to see is that if we see a byte that's valid, so if we saw one that was 0 0 that had 0 in the top bit, we would have let that through anyway, because it would have been a 1 byte character. So that would have already gone through. If we see B0, we shouldn't have seen B0 for anything, I don't believe. Yeah, right. So we should be skipping past this. Right, so we're going to be incrementing the result length here to 1 to say that we should at least increment past that. Ah, hang on a second. All 4, in the case that it was the 4 byte one, all 4 needed to be correct. So yeah, I guess. So I'll see what you're saying. This might not be right. Well, yeah. So that broke us out. So that's going to take us the result length back down to 1, 0 rather. And that's just going to keep cycling. I see. So I guess what you need to preserve is the knowledge of where you got up to, right? If byte 1 is equal to this, then basically what you're saying is that the possible thing is a 4 byte long thing. But the one that was incorrect, I think it was only the 4th byte, wasn't it? It was only the 4th byte that was actually not right. So you really want to be able to preserve the fact. You basically want to be starting off with your guy here, don't you? Starting off with I there. on that 4th byte. And then you just proceed through all of the malformed bytes. Right? Hold on a second. What are we actually checking for? We're checking for 0 0 and 1 0. But if this thing wasn't 1 1, So we got a 4-character long thing. Apparently, we apparently thought we were getting a 4-character long. I mean, in some ways, you just don't even know if that even you can't even rely on that. You know, because that could just be wrong, couldn't it? But then the next character that you see could be a valid character. Sorry, the next byte that you see, the second byte could be a valid character, right? Couldn't it? You know, it could be a valid 1-byte character, but you wouldn't know that. So I mean, it just sort of seems like if you see an invalid character, you just set the result 1 to the string length to be 1, and you just continue. Right, so you don't even bother to try and skip through everything and then put yourself back to where you think you should have been. So yeah, I think you just basically, if you see an invalid character, if you end up with any kind of invalid character, you just skip that first byte, I think. And then just fuck it. Tell Sarah Madden that the other thing got a thing wrong. Does that make sense? Because that is a conceivably reasonable outcome, isn't it? Jess is agreeing. Yeah, I mean, it does feel correct to me. I guess once you've also come down to here, you could just straight up fucking set the result to 1, the result length to be 1, so you don't need to bother checking it again. And it's only like when you get down here, it's that you sort of print the error, right? So this is just what will happen. It'll just be the number of thingamajigs we're replacing. Yeah, that's the point. Tell you what, if you get down to here, right, well, we're not actually storing this stuff anywhere. So it's like oh, I see what you're saying. I think if you see that, you just straight up set the value of that pointer to be that character. Wasn't it called special something or other? There's a specific car. There's our dude. So 00 FFFD. Right, should just be able to do that. Result length is 1, so multi-character car. Oh, that what? That's a multi-character, is it? Jesus Christ. Wait, is it? Oh shit. That's unfortunate. Because what's going to happen here, right, is we're going to come out of here, call this, sorry, we're going to come out of that fucking function, advancing by the character length of that, and then we're going to report this error, one handle character ignoring, and it's going to print this character somehow. So at least these guys are getting detected correctly. Got an invalid field T on line 1. So that was unhandled. This we can't even print that. Well, we sort of thought it was a apparently we thought it was a valid character. Which I can't even highlight. Is that even printing anything? Right, I can select that, but then it just goes to the rest of the line. So that doesn't seem to have printed anything. And then we've got this unhandled character ignoring. And this one was identified as an invalid character. So that's a 2-byte character. But that's a valid character, isn't it? I guess. Yeah, it's a valid character, and it's unhandled, right? So what I'm not understanding is why that hasn't printed out the entire thing. That is null byte. Can on. Gotcha. So that is null byte. To print the ones Vim shows in with that in blue. Ah. I mean, it shouldn't even realise that this ain't valid, because this is with a string. The blue ones. So 9, 8. So I'm getting a modified letter reverse comma. So that is 2 bytes. And I think we did remember seeing that this was getting recognised as a 2-byte character, weren't we? C3, 8A. Am I modifying that value? CA and 8D. I don't think I am. I'm always just saving off the thing, so the base. So that's setting that to be that. And then we're operating on byte 1. Right, we're dereferencing the B pointer. We're always just dereferencing we're never setting a pointer to the actual thing. See that into a message, a string or number. I'm never seeing the plus sign, am I? Maybe let's just step through it and just see exactly what's going on. Right, just go through the entire tokenization. Not the whole lot, but just from like one of them. The start. Skip white space. Not only detects like specific things. Right, so this is fine. We found that we've got a character that we don't know about. So we want to step in and see what we're dealing with. we've got a 1-1, so it should be a 2-byte long thing. And as I was saying, we found that it was a valid character. So we should enter this, and we should find that it's valid. Right, we do. Right, result length equal to 2. So we set the pointer correctly. We said the result length would be 2. We're going to return this, right? We're going to set the advancement to be with the car length, which should be 2, right? And then we do the config error. We should be passing the entire car to this function. Oh, there's an unhandled character. We received that. Sorry. Received that of length 2. So if we just print out so that doesn't seem able to print the whole thing. Well, not a character ignoring, yeah. We have got the receive thing. And then we're going to fprint the string with the length. Right. And this is still 2, isn't it? Right, that's still 2. So what happens when you do this? Bearing in mind I suppose another thing we could even do is run it again, go into that first call to the get character thing and just see what GDB prints for the pointer, because that thing usually manages to print out the entire things, the entire characters. Yeah, that's just printed out this particular person. Which was this. Yeah, so let's just run it again. Set the buffer, and if we just print out the B pointer, just get in there. I guess it's seeing this. So maybe that's just right then. So maybe that's just how that's getting interpreted by. Well, is that the same character? Yeah, I think that's the same character. So GDB is sort of seeing. Where's that guy gone? Oh, right, it's here. So GDB sees it as this, which is the guy that we're printing out as well. And then it sees this, and it's like, I don't fucking know what that is. But if we were to, I think this also printed out the same thing, didn't it? Because it was still there. If we just say that we're going to jump past a load of that, does this print out more stuff? It does print out more stuff. So it's succeeding. It's successfully printing out a bunch of stuff. It's getting Martin's Mosaico even. So the 1.0, that is valid, isn't it? Yeah, 1.0 should be valid with the 2-byter, which this thing is. So this is a 2-byter, and we're seeing the second byte having 1.0, which is perfectly valid. Let's just try and pull this stuff out. I mean, I wonder why Vim is printing out this character. Because that's what's throwing me basically here. I'm sort of expecting to see, I'm expecting to see this, right? The E with the circumflex. I'm expecting to see that as my first character, but, you know, I'm not. I'm seeing this, that guy, this thing. You know, GDB's seeing that as well. So it kind of makes me wonder, like, what is Vim doing? I guess trying another editor, just to see if that is the same. Don't even know if I have another editor. Okay, so that dude is printing out that character. So maybe Vim was just treating it differently, I guess. I'm not sure if this will be able to load it at all. No, that loads it like that. It's possible that LibreOffice is somehow fixing up some stuff. I say that because it's just it's a big program, basically. So I guess it's the kind of thing that might try and do. Failed to read the path from Java LDX. Yeah, I'm glad you failed to read the path from Java LDX. PT should work without the B. Ah, I see. Yeah, you're right. Okay, so maybe, yeah, unfortunately Vim in this one case has just gone crazy on us. I wonder what Forcoder does. Forcoder is printing out a CA and then a BD and then a 1.0 and then a 1.1. A 0.0. I presume that's what I'm looking at. I'm not exactly sure. Yeah, okay. So it's skipping like that. It's not able to print out Martin's Mosaico at all. So does Forcoder just not support Unicode? Yeah, all these characters are fucked up. Although the C, this one and then that is okay. And I think this character here is the 2-byter, isn't it? Although, I mean, maybe the whole thing has got thrown off. Although, well, got to remember that these top characters are all probably fucked up. Which might be throwing this off. How do you quit? New version, right, okay. Yeah, it's a very odd version of Vocoder, I think. Four point oh point 17. Four point oh point 29. Yeah, so I'm very, very far behind. 4.0.30. Oh, interesting that the 64-bit and the 32-bit Linuxes are off. Unless it's just a typo. Windows Firewall. I think somehow using D8 actually screwed up Unicode somehow. Not sure how, though, maybe. That screwed up from before, screws up later, I don't know. 1 meg. What was the 1 meg for? Was that for Vocoder? How do you undo close tab? Yeah. Yeah, look at this, 577k. So amazing. $32k right now. Should it mean 32 gig? Or do you mean, you sure you don't mean 4.0.32? So you're in a future version. So yeah, I mean, I guess I suppose I'm printing kind of the right stuff, maybe. Oh, your text editor is 32k. Oh, nice. And also, oops. Vim's 3.3 meg. But he does pull in some stuff as well. The installed side is 3.75 meg, but it also depends on GTK3. Which is 73.19 meg. The Vim runtime is 28.4, so yeah. talking about Vim being 3.75 is a bit of a cheat, because its runtime is this large. So your editor is 32 Mek. That's cool. Which Vim? This one. Yeah, exactly. So yeah, let's just have a quick gander again at how Nano showed it, just to see how that corresponds with anything like this, and just sort of 1, 2, 3. So there's 3 characters that it saw that I'm seeing as invalid. Well, sorry, 1, 2, 3. And then we've got another character ignoring. What am I seeing here? Another character. Sorry, yeah. This is being printed out by our interior function, by this actual dude here. Right. So when we actually come to emit the actual warning, we're doing that. So yeah, we've got that corresponding with this. So we've got 1, 2, 3. Let's have a look at Vim. Nano, rather. Yeah, so there we go. We've got your 3 unexplainable, unidentified flying characters. That. Then you've got that. Then you've got that. Then that. Apparently. And I'm seeing this, and then we're seeing nothing. And then we got the 1, 2, 3 before finally getting the actual character that we're kind of after, I presume. T equal, yeah, T is the first thing we actually see, isn't it? Because it's here, invalid field. This is the final thing that we actually end up getting anything remotely valid. So yeah, T is equal to that. So yeah, that does make sense. So we got the 1, 2, 3, and then we've got another unhandled character before this. We know that this is unhandled. The Greek question mark, which was down here somewhere, wasn't it? I think that's the, well, I don't think that's the Greek question mark. Guess I could just submit for it, can't I? Oh shit. Is that just, oh, it's a colon, is it? Okay. So we must have got rid of that Greek question mark. Fine, I guess. I suppose that was one of the, maybe that was there. It's one of these characters down here. But we got rid. So that's fine. We don't handle colons. Somehow we've, where's that coming from actually? Got to remember the Vim's got confused because of the invalid characters up at the top. So we've got that, then this. I think this character here should be this, and then this, and then back to the colon. Is the was the colon the thing that they gave it as an example? No, it was the dollar sign. But we used the hash, didn't we? Didn't we want to? Well, hold on. That's the hash. The character that they suggested was this person. for the fourth character. So there's 4, wasn't there? 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4. And then this is coming from somewhere. Oh, right. Ah, shit. It's just that one. Right? That's all that is. Because we're seeing that t equals c, which is sort of valid. We handle c, so we're going to tokenize those fuckers. But then we see that colon, so that makes sense. And then we just got this garbage up here, so it's going to be that, this, that, and this. So I suppose that's kind of correct. It's just a question of reporting like a malformed character, really. What do you call those guys if it's just not a valid character? Some of the important features of the encoding are as follows. Jobs are good. Just ship it, you reckon? Forgot what I was looking at now. What I was trying to look for. I was sort of thinking about printing out. Need to leave to be done soon. Cool. Enjoy dinner, dude. Yeah, it was printing this, wasn't it? That's what I was sort of thinking about. I think that's what I was thinking about. Oh, it was 14 errors. Yeah, I've completely lost what I was sort of thinking of trying to do. Self-synchronization. It also means the starter character can be found from a random position, backing up at most 3 bytes to find the leading byte. An incorrect character will not be decoded if a stream stops midstream and a short stream never appears on a longer one. Trace of lead byte. Oh, that was it, wasn't it? I think I was going to try and see what they'd have to say about invalid byte sequences. There's your replacement character. Why is this not able to fit in a byte though? Right? FFFD. Oh, because yeah, right. Because of the whole rule. The top byte is a non-zero. Not all sequences of bytes are valid UTF-8. UTF-8 decoders should be prepared for the red invalid bytes in the above table. An unexpected continuation bytes. A leading byte not followed by enough continuation bytes, we can have a simple string configuration. So yeah, we are handling this, aren't we? A leading byte not followed by enough continuation bytes. Yeah, this is totally what we are handling. An overlong encoding is described above. A sequence that decodes to an invalid code pointer is described below. A sequence that decodes to an invalid code point. The high and low surrogate halves used by UTF-16 and code points not encodable by UTF-16 are not legal Unicode values, and their UTF-8 encoding must be not decoding unpaired surrogate halves makes it impossible to store invalid UTF-16 such as Windows file names. WTF8. What the fuck, 8? Wobbly Windows. Wobbly transformation format 8-bit. By Automat, this is what you guys were talking about earlier. Many Windows programs use the bytes these at the start of any document, so does UTF-8. Oh, I see. So, I mean, it's kind of similar to doing like a hash bang, isn't it? Except that we do it manually. Three garbage characters. Another requires not recommends it. I see. So yeah, invalid bytes. We're handling the leading byte not followed by enough continuation bytes. We're definitely not handling that because we didn't know about them. An unexpected continuation byte, we're not handling that. An overlong encoding is described above. In principle, it would be possible to inflate the number of bytes in an encoding by padding the code point with leading zeros. To encode the euro sign from the above example in 4 bytes instead of 3, it could be padded with leading zeros. Okay, yeah. Until it's 21 bytes long and encoded as that. Padding with leading zeros. One, 0. Oh right, so that's supposed to indicate that it's a 4 byte long thing. Right, so you just hard saying that is for thingamajigs long. And then you pad the thing. I think I understand that. Roughly. The standard specifies that the correct encoding of a code point using the minimum number of bytes required and not valid UTF-8. Yeah, I don't know. I don't know that I care about that. I mean, it's also worth bearing in mind that the only reason I'm doing any of this is so I can print something. Because when I without handling this at all, and you end up without handling this, and you find a non-1 byte long character in here that you don't handle. If you're not doing all of this stuff, then you end up printing out too many things and not the right stuff. Well, probably nothing at all actually. Which is kind of what we're seeing here, isn't it, really? I think I'm going to call it a day, because it's like, how long are we going? 3.5 hours. Down to 10, 11 gig left on the hard drive. Let's just step through to the second instance of this unhandled character and see what we get. I mean, I wonder if part of it is that this is part of this. The first time through, it sort of could be valid, but it ends up not being. The second time through, we realise that it's definitely not valid in the slightest. Let's just see if that theory is at all plausible. So basically what we're talking about doing is running to here to the second time. So we've printed out the first character, step into here, and what do we see? We've seen that, which could be a character. So it's going to try and print out that, I guess. Yeah, and there's just no way to know that isn't valid, I suppose. I mean, I guess you could actually check, couldn't you? You could sort of see if it's within our code range, if it's within our range of printable characters. I guess you could do that, couldn't you? So we're saying the result equals to 1, and now all we're trying to determine is if it is actually valid. Which this will be, yeah. So it's a perfectly valid character, but it just wasn't printable. What was it? It was a 0001, wasn't it? Which turns out to be 16. So in decimal. So we've got the data link escape character. Which you can't print. So we recognise that character as something that we don't handle. We try and print it and just print nothing, basically. So there we go. This guy has now printed out that. But why don't we print out that? This has also got this. Depends on this one. I mean, I guess GTB is now just handling it slightly differently to me. And Nano, I think, wasn't it? Wasn't Nano handling it differently? This time through, I think we encountered a completely invalid character, didn't we? Well, this is valid, isn't it? So we printed off. So we printed out nothing. Well, hold on a second. GDB reckons we print out this, but on the terminal we saw nothing being printed. And then again, we come in here. This should be valid. But yeah. So that prints if that's what that warning. And now we've got a 4-byter. So this is probably the first one where we don't have all the. This is just a malformed character. Right, yeah, we don't return from it. And then we don't pass any of these. And then we just don't pass that either. So we return that. Okay, I think I've kind of understood roughly what could be going on. But what I don't understand is why we didn't. Config warning, ignoring that. Config warning that, ignoring this. Oh, there's two of them. There's two. Yeah, two, and then we finally get the malformed thing. So yeah, it's just like. I understand why this is printing nothing, but because that was evaluating to 0. But this one here was evaluating to like that. This control P character. Sorry, it was evaluating to the 16, wasn't it? It was evaluating to this this one, DLE, which I suppose just gets printed out as, I guess, the terminal just treats that as nothing. It just prints nothing out. But GDB interprets it as a control P. I guess that's just what's going on. Like, can't I just do this? Synchronous idle, yeah, this is the character. So if I try and print this, if I try and make the terminal print this, what does it do? Yeah, so that prints the printf's that. It reckons it's a control V this time. So I guess that's just what's going on, isn't it? Seeing these as valid, but unable to print them, so that we don't handle them. And then we just got down into these malformed ones until finally we got all these unhandled. And then we've got this invalid field, which we determine when we actually come to parse it. Routine identify where it's put a string or number somewhere. Yeah, so that's going to be for the C. So receipt identifier C, but expected a string or number. Okay, so I think I'm reasonably satisfied that this is okay. This is okay as it's going to be, I think. So we just pop that back. And now, so we shouldn't have any malformations in this. We just have unhandled stuff. So we have. Well, we do have we do have a malformed thing, don't we? On line 85. Well, we've got a bunch of them. Is that what I'd expect? Line 85. So we're not seeing that. Not seeing that. Now these characters were valid, weren't they? So we started off the entire day with that. Does that work at least? So that isn't right. So that's interesting. Because that is a valid well, it's a well-formed character. So I reckon that isn't. I reckon I'm not doing it right. Conversion error in line 5. Let's just dive into it. So what is our current line here, first of all? Yeah, it's not actually that, it's tokens current line. Token set. Oh, it's result. So yeah, we're looking at line 85. which is this line here. We're stepping into here, and we should see one of our test characters. So it's a 1-0. Yeah, which will be malformed. Won't it? Yeah. None of these are actually like that. So it seems like we're hitting one of these dudes. Maybe. Yeah, I don't know, but I mean, surely undoing the file actually gets us back to where it was. You know, like, surely it can't be possible that the hex editing actually screwed it up in a way that it can't actually undo. Well, I mean, I guess it's not beyond the realms of possibility. So we're seeing this. But the character that we should be seeing, where's our test character? We should be seeing this, shouldn't we? We should be seeing 1111 0 0 0 0. And then we should be going in and looking at each individual byte. Bit. Yeah, byte. Each individual byte. So I think what I'm going to try and do, I'm going to write into that file once more this character. So it's 10348. Save. Oh, right. Conversion error in line 5. So that's what's going on. So what's going on line 5? Mine's Mosaico. Ah, has it just lost the let's just reopen it. Ah, hang on a minute. If I reopen, bollocks, it's just lost the, it's just got all, wait, it's just got completely lost. That's unfortunate. So I guess that's probably what happened. It just couldn't take it any longer. Right, I see. So conversion error in line 5. So unfortunately, I think it did persist, didn't it? Like the confusion followed by the dehexing has just got it completely scrambled up. Apparently it has written, but it still kind of hasn't. That is unfortunate. Something has got an upside down question mark. Yeah, I mean, I guess. What do you do about that? I guess there's nothing to do, is there? You know, like you get like a completely fucked up file. That's where you just have to tell them this ain't on. But if I mean, I think this should. So we managed to convert. You see, converted this. I guess I could stat this file, couldn't I, to see exactly what we're talking about. Is it stat? What's the? Just seen it as a regular file. Let's just try and get Martin's name in again. Where's my cursor? So now we get a conversion error in line 5. Again. So you just can't convert to Unicode now, can you? Fuck. Oh, wait a minute. Was it file? I see. So file ISO thingamajig thingy. So I want to try and convert that to UTF-8. What does the included thingamajig report as? So that's ASCII text. Let's just put Martin's into the included file. So that manages to save that converted. And that's managed to write that. So that's now UTF-8 converted. And that is still ISO 8859. So yeah, we need to somehow convert this main file to UTF-8. Wonder how we handle all of this. Like, is this going to pass? There's something up on line 79, 78. So it's this file, it's this character here. So that reckons it's a... It just doesn't recognise that as a file, as a character. Yeah, but that's now passing perfectly fine. I think I'll call it a day there. And then I think off stream I'll just try and figure out how the hell to convert this fucker to UTF-8. I'm not exactly sure what they're talking about here. I mean, maybe could I just copy and paste this into a new file? Like, what happens if I just do that? What do I get for that? That's ASCII text, so that's what I want. So now if I just go down to the where something was, and this was where I was trying to do the testing of this whole thing. Let's put the characters back in. It wasn't there, it was this something. So 10348 20 AC 0082 was I think the one that I used, and then finally the hash, which we don't handle. And now we get a conversion error. It just doesn't like that. But that was ASCII text as we wanted, right? ASCII text could successfully get converted to UTF-8 Unicode text. And now it's just going back to ISO 8859. And we did save Cinera too. Yeah, so something's a bit weird. I think maybe Vim's just got completely confused. He just doesn't know how to do anything anymore. So, yeah, I don't know. Let's call it a day. And I'll just figure out how to get this thing back into a situation where I can actually test some stuff in it. I mean, further than that, you just put everything in the include file and just fuck the you just forget about the original file. But surely there's a way to actually retrieve some semblance of something out of this. But anyway, yeah, let's call it there. I think errors plus UTF-8 sort of accounts for it. I mean, it was all UTF-8 in the end, but it was erroring too. So yeah, that's all for today. Thank you very much, Heroes and Heroines, for being here and for being beautiful, fantastic, and inspirational, and obviously heroic. Until next time, farewell for now.